In this video, we're going to be looking at the trapezoidal rule. And this rule is used to find areas under curves. So let's say you had a curve like this. Now, this could be split up into different trapeziums. Okay, and it won't give us an exact area, but it will give us an estimate of the area under this curve between two specific points. Now there is a formula for this which is given to you in the logbooks, and that is here. So the area is h over 2 y1 plus yn plus 2 by yn, y3, y4, all then to yn minus 1. Now what that means, okay, so the h then, that's the gap between those strips, okay, and that'll always be the same throughout the question. So all of those here, h, they're the exact same throughout these questions, so you only need one of them. And then, so the y1, that's just the first term, then the yn is the last term, and then you do 2 multiplied by the sum of the rest of the heights. And these are the heights, you can see there. So all those lines are your heights in this question. Okay, so let's have a look now at an example. So here we need to estimate the area under the following curve. So straight away we can see there our h, that is going to be 2. Okay, so I'm just going to write that as h equals 2, and that 2 is going to be the exact same throughout all of these. So we have 2 over 2, then y1, that's the first term, so that's going to be 3, plus yn, that's the last term, so that's 4.5, then plus 2 times the sum of the rest of the heights. So I've dealt with 3, I've dealt with 4.5, so then I have 4 plus 2.5 plus 4 plus 2.8 plus 3.2. Okay, now I can put this directly into the calculator, and that will give me 40.5 and its area, so I'm just going to write units squared. And that's it. Okay, let's have a look now at a previous exam question. So here we're told a field is divided into 8 sections as shown below. The width of each section is 3 meters. The height in meters of each section is given in the diagram. Use the trapezoidal rule to estimate the area of the field. So we're told that h is equal to 3. So we're going to have 3 over 2. Then y1 then, that's the first term. So that's going to be 4. Plus the last term, which is 8. Plus 2 times now the sum of the rest of the terms. So that is going from 5.8 to 6.5. So 2 times 5.8 plus 7 plus 6.5 plus 6 plus 4.8 plus 6 plus 6.5. And again, this can go directly into the calculator. And when we do that, we're going to get 148.5. And in this question, we're dealing with meters, so meters squared. Okay, the second part then of this question, we're told the area of the same field was re-estimated by applying the trapezoidal rule again. This time a different section of width 4 meters and a different set of section heights were used. As shown in the diagram, the area was found to be 145.6 meters squared. Use information to find the value of the height marked x in the diagram. Okay, so I'm just going to write out what I know and put what I know into the formula, and hopefully that'll help. So in this part now, the height is 4. So I'm going to have 4 over 2 times n. So again, y1 is the first term, so that will be 4 plus then yn, and that is the last term, so that is 8, plus then 2 times the sum of the remaining terms. And the remaining terms then are going from 6.4 to 6.2. So 6.4 plus 6.9 plus 6 plus x plus 6.2. Okay, so let's simplify here. So 4 over 2 will be 2. 4 plus 8 will be 12 plus 2. So let's add up all the numbers here. So 6.4, 6.9, 6, and 6.2. And when we do that, we're left with 25.5. And then don't forget as well, we have that x left over. Okay, so I'm going to have 2 now times 12 plus, expand this bracket, so that'll be 2x plus 51. I can simplify the 12 and the 51, so that'll leave me with 2x plus 63. Now I can expand this bracket and I'll have 4x plus 126. Then remember, we're told the area is equal to 145.6. So I'm equaling this then to 145.6 because that's the area under the curve. So then let's bring the 126 to the other side. It becomes minus. So then 4x is equal to 19.6. So x equals 19.6 divided by 4. So x is equal to 4.9. And that's our final answer.